Business.
How are you doing today, Mr. Townsend?
Good. Did you find your thing?
I did.
Good.
Yeah, someone had put it in the lost and found.
Oh, that's good. That's what I was going to recommend. All right, good morning, guys. We are moving on to our next unit since you guys took your test last time. So the 30-second overview of what we'll be doing the next few weeks is sections 1.9, 3.1, and 3.2. So that should sound kind of weird to you that we're going from a section in chapter 1 and then jumping to 2 sections in chapter 3. But section 1.9, what we're going to talk about today and actually next class as well. Normally we do this in one class period, but Miss Thomas planned this unit out and she has it spread out over 2 days, so it just makes it easier for y'all anyway. But 1.9 is over inverse functions. So we talked about inverse functions a little bit last semester with trig functions, but we're going to talk about specifically the algebra of inverse functions. Then we'll skip to section 3.1, which is exponential functions, which has nothing to do with inverse functions. But then in section 3.2, we're going to do logarithmic properties and logarithmic graphs. And logarithms are harder for some people, but logarithms are really the inverse of exponential functions. So if you really understand what it means to be an inverse function and their characteristics, and you learn what you need to learn in 3.1 about exponential functions, you can automatically apply some of that to section 3.2 about logarithms before I even tell you. So we've got some short notes here, and that book assignment looks a little bit long there, but it's not. You guys will have plenty of time to finish this up in class today and get all of your questions answered. So I guess before I start the notes, I'll just give a quick little reminder of how we used inverse functions last semester, just because it's kind of relevant, although what we're doing in this section is much easier than what we had to do with inverse functions in trig. But last semester we did a lot of trig stuff, so we would have something like this for regular sine functions. And then eventually we talked about inverse functions, and what that means is you switch the input with the output. So regular sine, you input an angle and it outputted a ratio, but in an inverse function, we inputted the ratio and it outputted, except it only existed in radians, it outputs an angle. Just switches the input with the output. So again, we're not doing the trig stuff today, but that still holds true. Why the inverse trig functions were harder is because we had to memorize the range of each of these. So there were 6 things you had to memorize, and you had to apply the unit circle with each question, which make those a little bit harder. But all right, so typically in an Algebra 2 class, probably how your Algebra 2 teacher described to you how to find an inverse of a function is to swap x and y, and then solve for y. That makes sense in algebra because you often use x's and y's, but again, it's kind of important to understand that you're really just swapping the input, which is usually x, with the output, which is usually y. It's better to think of it as input-output because then it's easier to translate to trig too. So, one quick example. You may have some questions that say find the inverse of something. So, again, just 2 steps really. Switch x and y, and then solve for your new y. So undo +1 and undo times 2. The only thing that we really need to do extra, I don't really consider this a step, but we know f of x is really the same thing as y. So y can't be 2x plus 1 and be x minus 1 over 2. Like, these are 2 different things. We shouldn't be using the same variable for them. So if the original function is f of x, the inverse should look like this. Looks like f of x with kind of a -1 exponent. It's not really a -1 exponent, but that's what it looks like. And just to make connections for you here, in trig, it was the same idea. When we're talking about inverse sine, he looks like he has a little -1 exponent. So, easy algebra steps to find a function's inverse. Now, if you want to prove or verify or show that two functions are inverses of each other, there's only one way to do that, and that's algebraically. So you can either do f of g or g of f. This open circle means composition of functions. Sometimes it's written like this, and sometimes it's written like this. This is when you plug a function into another function. So f of g, that looks like the word fog, but again, it's not an O, it's an open circle math symbol. It means you're going to plug function g into function f. G of f means you're going to plug f into g. And if they are really inverses of each other, both of these will simplify to be just x. So, an example of that, here's the same y equals 2x plus 1 and the inverse that I got on the second question. So if you were asked to verify these are inverses or prove that they're inverses or show that they're inverses, this is the only way to do that. You would have to show taking this guy and plug it in here. And then after a step or two, simplifies the x. And you have to show the other direction as well. If you plug this one into that one, plus 1 minus 1 cancels, times 2 divided by 2 cancels. Yeah.
Is it possible for it to work one way but not the other?
Yes, and that's why we have to do both directions, but it's very rare. Like, I can't think of a counterexample right now. But yes, you do have to show both directions. Plugging it in one way and simplifying the x is not enough. You got to do both. Now, I'm going to say this just to try to help deter you from this. Sometimes, and I don't know why, when the directions say this, students will find this guy's inverse and show that it's this, and then find this guy's inverse and show that it's that. That is not good enough to verify or prove that they're inverses. You need to do it this way. This is the only way to do it algebraically. Now, depending on how you're using it, verifying that they're inverses graphically can sometimes be good enough. This doesn't work 100. It's not foolproof, which is why we can't rely on this method, but this is usually good enough 99% of the time. So this would be great for like the ACT. Like if the ACT said which one of these functions is inverse to this function, what you could do is you could graph both of them, especially in your calculator if it was ACT. And if they're really inverse functions, there will be a line of symmetry at y equals x. Just like when you plug them into each other and they simplify to x, same reason that guy equals x. So again, even though I can find the inverse of a function algebraically, if I was taking the ACT and I had access to a calculator, it might be quicker to graph their function and graph choice A, see if there's this symmetry. If there's not, graph the function and graph choice B and see if there's a symmetry, and that might be quicker. So to have a visual of this, again, same two functions, so we know these two are really inverses of each other. Let's go ahead and try to graph both of these, and you really, for your notes here, you want this to be as accurate as possible. It's a little easier to see what you need to get out of this. Okay, so if we graph 2x plus 1, that has a y-intercept of 1 and a slope of 2. You only need 2 points to define a line. And for his inverse, you may want to split that fraction apart makes it a little easier to see. His slope is 1/2 and his y-intercept is -1/2. So plot the y-intercept, count rise over run. So that would be step 1, graph both of the functions. And then step 2, I would also just go ahead and graph y equals x, which is this line. It's the line that contains the points where x and y are the same thing, where x and y are both 1, where x and y are both 0, where x and y are both 2, etc. And that's supposed to be a line of symmetry. So it cuts my overall graph in half, and hopefully you can visualize this. The function, which is in red, could flip over y equals x and land on his inverse, the purple one, and or you could take the inverse function, which I graphed as purple, flip it over the y equals x line, and it would land on the red line, which is the function. If you flip it over that line, it should land on its inverse, and its inverse should flip over and land on its function. So the only reason this doesn't work 100% of the time, it's not good enough for a proof, is because we can eyeball this and there looks like there's this line of symmetry at y equals x, but one of these could just be a tiny, tiny, tiny bit off. So that's why it's not good enough to prove. And honestly, I should take this word off. This shouldn't say verify. We're not really verifying. We're pretty sure they're inverses based on that graph. But okay, I'm going to come back to this graph at the very end here because there's one more thing I want to point out about it to you. But I also need to remind you, a lot of this stuff we talked about last semester, but vertical line test is the test that tells you if a relation is a function. So if you can draw a vertical line that hits your graph more than once, it is not a function. Then we have this horizontal line test that tells you if a function has an inverse function. And then I need you to squeeze a term in here. You also need to know what it means to be one-to-one. This shows up in this section. And I know the term one-to-one, unless something has changed, it gets thrown on the ACT. But to be one-to-one just means it passes both of those tests. Passes the vertical line test and the horizontal line test. It means it's a function and his inverse would be a function. Okay, and then the last reminder I think you need before we can practice, although I'm going to show you this on the graph in a second too, is you need to make sure that you understand how points on a function relate to its inverse and vice versa. So let's just make up a couple fake points on a function and talk about what the points would be on the inverse. So hypothetically, if a function had points at, I don't know, 0, 1, 5, -2, and 7, 11, that means we should also know 3 points about the inverse. Because all an inverse means is you're swapping input and output. You're swapping x and y. So 0, 1 becomes 1, 0. 5, -2 would become -2, 5. 7, 11 becomes 11, 7. So I'm not changing the sign. I'm not switching whether they're positive or negative. I'm just switching the x with the y. Okay, and then to relate that to the graph, I just want you to see that this is consistent with this. The function had a point at 0, 1, which guaranteed that the inverse was going to have a point at 1, 0. The function has a point at 1, 3, which guarantees his inverse would have a point at 3, 1. any point you know about the function should give you a new point that you know about the inverse, and any point you know about the inverse should give you a point that you know about the function. Okay, before I throw up the book assignment and let you try the first few and see how it goes, is there any immediate questions? Anything you want quick clarification on?
What did you, what's the 1/2 x minus 1/2 on the,
This,
where we cross out verify? Yeah, what was that actually?
I graphed this, and so I just split apart the fraction so I could see the slope and I could see the y-intercept.
Yeah, okay.
It's the same as this, it's just, this is a little easier to think of when you're graphing, so that's why I did it that way. Okay, so I have several of these worked out on the website, but not all of them. This is maybe the first assignment that's not everything worked out, but I have all the questions that my first and fifth period asked yesterday. But you guys may need to ask a few more, so I'm only warning you of that to make sure that you know that you need to ask what you need to ask. So, blank piece of paper for 86. The first 6 questions are all vocab questions, so those should go very quickly. And about 10 minutes from now, I will let you ask for a question or two to be worked out on the board. And as we've done in the past, I'll just do that a few times to make sure that you get everything answered that you need to get answered. Now, I also have a practice quiz for you guys in this section. But again, for whatever reason, Ms. Thomas spread this out 2 days instead of 1 day. So most years, you guys would do the book assignment and the practice quiz today. But this year, you can just worry about the book assignment today and then worry about the practice quiz on Tuesday. In case you haven't noticed, this is an A week too. I know last week was an A week, but since there was no school on Monday, that means Friday is an A day this week. So I won't see you again until Tuesday. Yep.
Based on my understanding from my other teachers, on Tuesday with the ACT, it will be like 20 minutes. Are we going to do anything on that day?
I have not seen the schedule, so I can't say that it's going to be 20 minutes. I don't know that that's.
Do you have anything planned, like what?
If it's 20 minutes, then no. I would give out the practice quiz, but I actually have it printed out now, so I could give it to you today too. But I don't know that that's the case, because in the past when we've had testing days, it pretty much ruins the whole morning, and then afternoon is really short. But they're trying to fix that this year. And like last week when we had a testing, it really it only made each class 20 minutes shorter, so it didn't change too much. So I don't know. I haven't seen the schedule because I don't proctor the ACT. So, but yeah, if it's only 20 minutes, we won't count that as a day. I would prefer you guys just to put that extra effort into your ACT. Now, even if classes are only 20 minutes though, there still will take attendance and stuff in the afternoon. So if you're not going to be here, just make sure your parents call and excuse it so it doesn't mess with your exemptions and stuff. question is it?
Number 10.
Inverse, so that would be 2x plus 3. Okay, but so this guy is y though. You shouldn't call this guy y. Call him
F of x.
with the little -1
Oh.
exponent thing.
Alright.
And you need the second part of the question too. You need to plug them into each other to see. And then that would be a way that you could have checked too.
Thank you.
No.
Okay, it's almost been 10 minutes already, so is there any of the 6 vocab that you couldn't find, or any of the other first few? 10, 15, 18? Yeah, ready? I'm sorry? Number 2? Number 2 is saying the inverse of f is denoted by this. They just want you to say what the notation for its inverse would be. Yeah.
What is 4?
Number 4, the graphs of f and his inverse are reflections of each other in the line y equals x. Okay, is that it so far? Okay, go ahead and keep going then. And I know some of you will be able to finish this up in about 15-20 minutes or so, so just make sure that you please turn it into Google Classroom so you don't run the risk of losing it and forgetting about it, or forgetting about it.
just those numbers you're looking at. You really need to see all the points, which is the graph.
Okay, now that you've had a little bit more time here, it's been about another 12 minutes or so. Is there something else you have found I can help with?
Number
82?
18.
Oh, 18, sorry. Let me make sure I don't have this. Do. Okay, 18 asks us to verify that f and g are inverses algebraically. Okay, so the only way to verify that they're inverses algebraically is by plugging them into each other. So we need to figure out f of g, which is where we would plug g into f. So instead of x cubed plus 5, it would be this stuff cubed plus 5. And then we need to simplify. So cubing a cube root, those are inverses, so those cancel out. And then the plus 5 minus 5 cancels out. So that side works, but you have to show it the other direction as well. So you also have to show g of f. So that's where you would plug f in for g. So instead of the cube root of x minus 5, it's going to be the cube root of this stuff minus 5. And then we have to simplify. So plus 5 minus 5 goes to 0. And then cube rooting a cube cancels out and leaves you behind an x again. So showing that plugging g into f simplifies to x, and plugging f into g simplifies into x. That's how you verify algebraically. You got one?
29.
29. Okay, 29 wants us to do algebraically and graphically. Okay, so if I do f of g, that means g is going in place to f. So you would get 1 over x. You okay with that?
Mm-hmm.
Okay, and now to simplify this, you have to remember that dividing fractions is the same as multiplying by the reciprocal. So dividing by 1 over x is the same as multiplying by x over 1. So that's how you get that to simplify to be x. And then if you do f of g, you're plugging f into g, but it's almost kind of silly to do that because you're plugging the same thing into the same thing again. So of course it's going to simplify the same way. So there's the algebraic part, and this is one of very, very few examples of functions that are their own inverse. 1 over x is inverse with himself. That's not normally true, but it is for 1 over x and a couple others. Then for graphically, if you graphed both of these, now both of these are considered to be parent, well, they're the same graph, but they're considered to be parent functions. They're a little bit lesser known, but at some point in Algebra 2 you probably memorized these. But 1 over x looks like this, and 1 over x is going to look exactly the same because it's the same thing. And so to do it graphically, you should graph both of them, and then notice that y equals x is a line of symmetry. I could flip the red graph over y equals x and it would land on the purple graph, or I could flip the purple graph over y equals x and it would land on the red graph. and it cuts my overall picture exactly in half.
Isn't that -1 for x?
Oh, you're right, you're right. I did too quickly. Right. There we go. But the rest of it still stands. Okay, is that enough for 29?
Yeah.
Any others you guys have ready to go? Yeah.
39.
39? Try to sketch this graph first. Okay, so 39 just wants to know, does the function have an inverse? So they're telling us that this is a function, but we should also know it's a function because he passes the vertical line test. Any vertical line I draw hits the graph at most once. But for his inverse to be a function, he needs to pass the horizontal line test. And he fails the horizontal line test because I could find at least one horizontal line that hits the graph more than once. And if he does not pass the horizontal line test, then no, his inverse is not a function. So easy to apply the horizontal line test, but you have to know when they're asking you to do that, which is what 39 is about. Okay, let me give you a little bit more time, and I'll put the assignment back up in case you haven't copied it down yet. You guys are asking a couple of different questions, so I will put those up as videos on the website, just in case you're working on something else and decide you need help with them later. can see some of you guys are finished up, but let me offer to work out on the board one more time. Of course, I can still help you after that as well, but. Anything else from the book assignment that I could help on?
Can you show me do 61?
61, sure. Okay, so if you only look at part of the question on 61, it looks like this. And you're supposed to figure out if the function has an inverse, and if it does, find the inverse. Well, to know if this has an inverse would mean that he would have to pass the horizontal line test. So if you graph this, this is going to look like x squared shifted left 3. So if you're only paying attention to that part of the question, you would say no, this doesn't have an inverse because it doesn't pass the horizontal line test. But it also out to the side says only the part of the graph where x is greater than or equal to -3. So it's telling you to just keep this part and not that part. And because of this restricted domain, now he is 1-to-1. So yes, he has an inverse, or yes, its inverse is a function. So we need to find that inverse function. So take the function, swap x and y, and then solve for y. So undo the square with the square root. Undo a +3 with a -3. And you probably shouldn't call it y anymore. You should call them the inverse of f. So even better, even though this is optional, but even better to go ahead and graph this guy as well. It's really good for you to know what the square root of x looks like. It just looks like this. Shifted down 3. It's going to look like that. And the reason why you might do that additional step, even though it doesn't say to, is because then you can see y equals x looks like a line of symmetry, which should make you feel good about your answer. Yeah.
91. It just doesn't make sense.
91. If f, this one. 91 says if f is an even function, then f of x, or I'm sorry, his inverse function exists. Okay, well, what do you remember about even functions? Or specifically the graph of even functions?
They are, yeah, they're symmetrical on the graph, but they don't center around the origin.
Okay, so they're not symmetrical about the origin, but they're symmetrical to the...
Y-axis.
Okay, so something like x squared, people often remember that's an even function. He's an even function. Well, is his inverse a function?
No,
How come?
it doesn't pass the horizontal line test.
Right, and so if an even function is always symmetrical to the y-axis, that means that anything that's over here has to be over here, which guarantees it's going to fail the horizontal line test. So an even function by default does not have an inverse function. Unless, like question 61 that you guys just asked about, this guy is an even function as well. Well, I'm sorry, this part's not. But sometimes if you restrict the domain and just choose to look at part of the graph, then you can make an even function do that. But by default, even function, symmetric to the y-axis, and if it's symmetric to the y-axis, it doesn't pass the horizontal line test, and if it doesn't pass the horizontal line test, the inverse is not a function.
Thank you.
Sure. All right, keep them coming if you've got others. Yeah.
89.
89? Okay, 89A. Your wage is $10 per hour plus 75 cents for each unit produced per hour. And then they even set up the equation for us. Okay, A wants us to find the inverse function and then say what each variable represents in the inverse function. Okay, so the first part's going to be easier. Just switch x and y. And then solve for your new y. So undo the plus 10. Undo the timesing by 0.75. And now this is his inverse. But you kind of have to dig a little bit deeper to think about what the new variables mean. So I think the easiest way to do that is to first ask yourself what the variables mean up here, because they tell us that. X was the number of units sold, so it's like you're getting a commission. And then Y is how much money you make. So in an inverse function, if you're just swapping the input with the output, now in the inverse function, Y is going to represent what X used to mean. So Y is going to represent the number of units sold, and X is going to represent what Y used to represent, because they just switched places, and X is going to represent how much money you have. So this, again, this idea of this function's great if all you care about is you plug in the number of units you sold and then you get an idea of what your paycheck's supposed to be. But if for some reason, you know, you get your paycheck at the end of the month and you know what your paycheck is and you just want to plug that in and then you want to solve to see how many units they think you sold, then this, writing it this way would make more sense. And that would be like if you were trying to check your paycheck to make sure they paid you correctly. A lot of times businesses do mess up paychecks, so it is good that y'all get in the habit of checking that stuff so you don't get cheated. All right, well, with our extended period here, we've still got about 33 minutes-ish. So I think we've exhausted most of the questions, but if y'all find something else, feel free to call me over or bring it up here to me. And I will ask this to be turned in before we start class on Tuesday. So as you finish, you should probably just go ahead and turn it in, and then you don't have to worry about it.